Alright, this time value of money concept deals with annuities, and specifically we're going to look at the present value of an annuity. So an annuity is requires of periodic payments or receipts of the same amounts. There's the same interval of time in between such payment, and the compounding of interest occurs only once during that interval. There are two types. The first is an ordinary annuity, where the payment occurs at the end of the period, like at the end of the year, and annuity due, where the payment occurs at the beginning of the year. So when we were doing the future value of an ordinary annuity, we were looking at the payments, payment 1, payment 2, payment 3, and we were trying to project what those values would be in the future. Well, we might also want to know what those values are then in present dollars. So the idea is that we figure out these future values of these payments and then convert it back to present values. We have a formula and tables that will allow us to do that two-step process in one step. You can see the formulas here. The present value of payment 1 plus the present value of payment 2 plus the present value of payment 3. Okay, the formula that we use, again, is what I've just described. The present value of the annuity, present value of payment 1 plus present 2 plus present value of payment 3. It can be summarized down here as the payment is this formula. I have maybe a little bit easier explanation of this formula coming up in a second. I'll let you look at that, study that longer. If you need to, you can come back to this. Okay, and when we are solving for present value, there are 4 variables, and we're given 3, and we're computing the 4th. So we might be looking for the present value of the annuity itself. If so, we need the payment, the interest rate, and the number of periods. Again, a more simplified version of that formula is 1, and it's not simple, but just more simplified. 1 minus 1 divided by 1 plus I, that's the interest rate, raised to the nth power divided by the interest rate. And of course, then to find that present value, we take that payment multiplied by that factor. Okay, so let's take a look at the various tables we might be using to find this. This is the present value of an ordinary annuity. Commonly this is referred to as table 4. So in this case, someone wins $2 million in the state lottery. She will be paid $100,000 at the end of each year for the next 20 years. How much has she actually won? Assume the appropriate interest rate of 8%. So a lottery payout is a common one that a lot of people are familiar with. Most of you know that if you win the lottery, if you take the lump sum amount, it is quite a bit less than what you've won, and of course the reason for that is this time value of money. So the table we use is table 4. It is the present value of an ordinary annuity. So let's take a look at this. Let's assume an interest rate of 5%. I don't think that's right. I think we're using an interest rate of 8%. So that is a mistake. Let's assume an interest rate of 8% for 20 periods. So 8%, 20 periods. We get a present value factor of 9.81815. So $100,000 times 9.81815 gives us a present value of $981,815. So if we were to win $2 million in the lottery paid out over 20 years, that is the equivalent at an 8% interest rate of earning just a little bit less than winning just a little bit less than $1 million all paid up front. If we're going to solve this in our financial calculator, again, N is 20, interest rate is 8%, our payment is $100,000. We then solve for present value, and that is the $981,815. Okay, I hope this short presentation helped you understand the tables or how to do this in your financial calculator.